Hi folks, welcome to my replication of Nikola Tesla's rotary engine and compressor. It's actually set up in compressor mode at the moment. It's from British patent 24001. It's also hidden partially in US patent 1061142. I've been posting about that on my Patreon channel, which is www.patreon.com/Tesla Turbo. You can find out much finer details in there. Just thought I'd show you the setup. I've got the friendly neighbourhood starter motor, Mr. Henry. I've got a tachometer, a cooker lighter and a vacuum pressure gauge, essential tools for testing these machines. I'll just talk a bit more about the setup now. I've got the volute casing from those patents. I've got passive magnetic bearings, and I've got dual bearings for the Z axis. The passive magnetic bearings just take care of the X and the Y. As I said, I've got it currently set up in compressor mode, and the rotor is restricting the flow. It's not been machined for optimum airflow yet. And it will be soon, but I just thought I'd show you it before I make the modification so you can see what it's like now and then what it's like afterwards. So I'm just gonna these tachometers, unfortunately they don't hold on. I think that's so you don't leave them on, which is partially good, but it'd be nice if they made them with an on-off switch. So I've just got a hair bobble to hold that. But I'll just switch the vacuum on, and you can see I've got a tack mark there. It started moving, so you can see there's a strong vacuum there. See, what will happen is, although I'm blocking that, and we're getting about only about 3 inches of mercury, the inner bit there. What's happening is something in there. And there as well. You could prevent that by you could have a labyrinth seal there or some sort of seal, but you need something that doesn't cause friction. And you can see, because it's restricted, the acceleration is really slow. We're only at like 384 and 90 RPM. We'll just turn the vacuum off for a second. Still going up. You can hear how quiet it is. Pretty quiet, but I'll just turn the vacuum back on. So it's still going up, but very, very slowly. So the spiral path at the moment is coming in. It's coming in there, and because of the shape of it, it's going round that way and coming out here. The volute acts as a fluid diode, and I don't think this has been understood by a lot of people yet. I think it will be in the not too distant future, but the volute casing is a mechanical fluid diode. You have to take my word for it, but the truth will be revealed. You can see it's not going up particularly fast at all, and that is due to the large restriction of the rotor, because the rotor at the minute is as wide as what the the pump rotor would be in figure 1 or figure 2 of British patent 24001. Or US patent 1061142. So I've been calculating the optimum width for it, and I think some testing is definitely going to have to be done to finalise what that is. And Tesla didn't draw it, so he only left a description that would be understood by those skilled in the art. And to become skilled in the art, you've got to build these things. You've got to build these things and do testing. Otherwise, you're just reading text that doesn't really make full sense. You might think that it makes sense, but it's written in a very clever way to make proper sense once you become skilled in the art. So it's still going up in decimal places. Sometimes 1 RPM, sometimes less. But we'll leave it for a bit longer. So this is Henry, a friendly neighbourhood starter motor. It's actually a 620 watt vacuum. I took the bag out just to give it a bit better flow. It does actually pull about 6 or 7 inches of mercury, sealed. I'll show you that in a bit. So still going up, very, very slowly. Right, we've got to 800 RPM. Kind of boring, just sitting there. It'll go up to about 1,000 and keep going, but it starts going up in decimal places. So I'll switch off the vacuum so you can hear how quiet it is. And just a quick check on what's going on. That's blowing. That's sucking, as you'd expect from a compressor, but because it's blocked, it isn't sucking or blowing very much. You can hear a very, very slight noise from the bearings, but bear in mind this rotor hasn't been balanced yet, so considering it hasn't been balanced, it's sounding pretty good. Right, I'm just going to show you the vacuum from the vacuum cleaner. Right, so we put that in there loose first. I'm going to switch it on and then block it off. So you're looking at about 6.5 inches of mercury there. That's tops. Okay, now what we're going to do is I'm going to put the vacuum, a friendly neighbourhood starter motor, into the back, into this vacuum cleaner adapter that was specially made for this. Right, so just see what the RPM is now. So it's slowing down. So, right, I'll switch the vacuum on. This is in rotary engine mode, which if you don't know, it's got another name. I'll tell you about that in a bit. So you can see it's accelerating a lot faster. Still got the same restriction as the compressor mode, but in this rotation it's taking energy from the medium rather than adding energy to the medium, which is evidently shown by how fast it's accelerating in comparison. Sorry about the shaky camera hand. Bear in mind this isn't balanced at all. Well, I've only taken it to 4,000 myself so far. I'm going over that on this test to show you what happens. I'm not going massively over. Because I know there's a big blockage. The dual bearings are lubricated with cooking oil. I think that's hilarious. spin up at 8 RPM a second, roughly. I'm going to stop at 5,000. Okay, so now you'll be able to hear, you can hear it a little bit. But is the noise the actual rotor vibrating rather than the bearings? Now you can see it's not sucking, it's blowing, and that's because there's a restriction inside. See, it's sucking from there, blowing from there. It should be doing the opposite. And that's because the actual area going in here is 4.2 times bigger than the exit area around the side of the rotor. So the next step is to remove some material from the side of the rotor so that the line of least resistance is that way, and because the rotor's spinning this way with the flow out, once the line of least resistance is going in that direction, that won't be blowing, it'll be sucking, at which point atmospheric pressure has then got a new path. So essentially it's a mechanical draft through the machine. I know from testing other rotors that are not in the volute casing, the circular bore casing, at 5,000 RPM, that would be blowing a lot, a hell of a lot. This is completely different. I mean, can you hear the bearings slightly? You can see the little tiny blob of oil, on the cooking oil on the tip. But it's quiet for the speed. So we're down to, steady my hand. So we're dropping quite quick, but not too quick. But the imbalance will cause that to drop faster. But I just thought, you know, before I modify the rotor so that the escape pathway isn't restricting the flow, I thought you'd like to see it as it is, and so you can compare the results after I've modified the width of the rotor. I think it's going to be very interesting, and also it's very interesting that you can run the rotor this fast with hardly any noise, and well, it'll be even less when it's balanced. Don't forget, noise is a loss. There's a loss in energy, so it's going to be interesting once it's balanced, once the right amount of material's been removed. That's why I haven't got it balanced yet, because I thought there's no point. There's no point getting it balanced if it still needs material removed from the rotor. It's just a waste of money. And it's like £200 to get it balanced. You know, it's a lot of money to just throw away. So if you want to join the deeper research study of these machines, you can come over to www.patreon.com/Tesla Turbo, and we go into some very deep discussions of Tesla's work, these machines in particular. See, like the slower that the RPM goes, the less of the drop, because the imbalance isn't magnified so much at lower RPMs. It sounds to me like this bearing's the one where the noise is coming out, and then this one's completely silent, because what happens is this needle point, that the axle's thrusting that way very, very slightly, which means that this one, it's just feathering, it's barely touching. I can put some adjustment on that, so I can stand this up vertically and it will actually sit on a top needle point, or depending on which way I tip it. I mean, it could be that one or that one, but I could adjust it so that it will sit on a top needle point, so there's actually no weight on the needle point really. It's kind of just like using it as a place to stop it moving at all, but barely feathering it. So it's dropping 5-6 RPM a time at the moment. So yeah, it's an interesting, it's a very interesting machine, and adding the nearly frictionless bearings, or almost contact-free bearings, it definitely changes the dynamics of things. I mean, Tesla was using aerodynamic bearings, for those that don't know. Originally patented by Westinghouse in 1904, and by 1909 Nikola Tesla had made his own version, which was actually a horizontal axle, or a vertical axle, because the original Westinghouse patent was a vertical axle using either atmospheric pressure or compressed air. Don't forget, atmospheric pressure is compressed air. Yeah, if you've not seen that, it's worth checking out. Should be able to find it by an easy Google search. Westinghouse turbine air bearing, atmospheric bearing. So you can see now it's dropping like 3 RPM a time. That noise. I mean, it'd be interesting to see how long these tungsten carbide needle points last. They've got a very fine adjustment on these. You can, I'm sure I could adjust that so most of that sound's gone, because I know when I last ran it to at 4,000 RPM, it was even quieter than that. So I am working on a design that features a special magnet here and here. It was actually designed by a chap called Colin, who posted on YouTube. He's a mechanical engineer that lives in Australia, if I recall rightly, and yeah, he's given me a design that, but we need to get custom magnets to take care of the Z-axis, so that would be completely noise free, apart from the rotor spinning around, and completely contact free, so not frictionless but nearly frictionless. So it's still falling about 2-3 RPM a time there. So as I said before, any noise on a bearing is a loss. So I know we can dial that out I'm waiting for a special spanner to arrive, because the spanner that I use to adjust these nuts and the see the flat, where the flat blade screwdriver goes in there. So when I adjust them at the moment, the spanner is violently attracted to that side, which makes it quite difficult to adjust. So the new spanner's made out of aluminium bronze. That would make things a lot easier. Yeah, I mean, this is going to take quite some time to stop. Still falling at 2 p.m. 2 p.m. 2 RPM. So